Okay, let's study about the Bohr's theory of hydrogen atom. What Niels Bohr, a Danish physicist in 1913, explained how does an hydrogen atom would look like. So what are the details he has given about the hydrogen atom? Although hydrogen atom is the simplest atom containing only one neutron in in the nucleus and one electron revolving around it. The first point says that the principal quantum numbers will have value of n is equal to 1, 2, 3. Bohr says that the electrons, when while revolving around the nucleus, they will be in some stationary states. Stationary instead, they are in some stable states. Only at some places they are allowed to move around the nucleus, and those are stationary states. And while they revolve, while they are in stationary states, they will not emit any electromagnetic waves or waves, which was in contrast to Maxwell's James Clerk Maxwell's observation in 1870, which says that any charged particles, when accelerated, they will emit an electromagnetic radiation. It was against that. According to Bohr, if the electrons are in the stationary states, which are numbered, they would not emit any kind of energy. They will be stable. So those numbers are called as principal quantum numbers, and they have the value of 1, 2, 3, 1, 2, 3, 4, not 1, 1.5, 2.6, 3.7, not like that. They have in integral value 1, 2, 3, 4. It will go like that. So these are the quantum numbers. In fact, the principal quantum numbers, the first kind of quantum numbers is the first term that has been used here by Bohr in describing the hydrogen atom. Now, while they are in stationary states, they'll be moving in the orbits, a fixed path around the nucleus, and so since it is a circular path, its radius is given by n square multiplied by a naught. A naught is a constant called Bohr's orbit, and it has a value of 52.9 picometer. Pico is 10 to the power minus 15. So this is the value, and the radius will depend on square of n. What is n? The principal quantum number. It may have a value of 1, 2, 3, 4. If it is a first orbit, and it will have if it corresponds to the first principal quantum number, its value will be 1. So 1 square is 1. 1 into 1 multiplied by this will be this. So the first orbit will have a radius of 52.9 picometer. The second permissible orbit will have value of, then it will have principal quantum number 2, so its value will become 4 times this. Then the third stationary state, similarly, while electron is in a third stationary state, its radius will be 3 square multiplied by this 3, that means 9 times this. So it varies in times, square times. Now, while in this radius, what will be its energy when they are in this particular orbit? It is given by minus RH by n squared, where RH is the Rydberg constant having value 2.18 into 10 to the power minus 18 joules. So it's a very small energy, 10 to the power minus 18 joules. It's a Rydberg constant, and it is varying as per the principal quantum number. For example, it is in the first, if it is moving in the first stationary state where n equal to 1, where principal quantum number equal to 1, then it will become 1, 1 square is 1, so the value will become this. So when an electron is moving in this radius, 52.9 picometer, which corresponds to principal quantum number 1, then it will have an energy of minus 2.18 multiplied by 10 to the power minus 18 joules. So when it is in second orbit, the second stationary state, then its value will be 2 square 4. This value divided by 4. So its value obviously lesser than this in absolute terms, but it has a negative sign. That means that value in negative sign, when it's smaller, its value, its quantity is said to be more. So the absolute value will be less, but since it's a negative, it will have more. It will consider that it has more energy. In the second orbit, the energy will be 1/4 of this. 1/4 of this. And in third orbit, it will be 1/9 of this. Third orbit means the principal quantum number will be 3. 3 squared is 9. So 1/9 of this value in absolute terms. But since it has negative sign, it will be considered to have more energy. The fourth point, it's the Bohr's theory says that it can also calculate the radius and energy of those species which are similar to hydrogen atom, which contains only one electron. For example, helium positive, lithium 2 plus, or barium 3 plus, 3 positive. These species have one electron in their shell. For example, here one electron has been removed. Helium has two electrons. One has been removed, so it has one electron. Lithium has three electrons in its atom. Two has been removed, so it will have one electron. Barium has four electrons in its atom. Three has been removed. Three plus means three electrons are removed, so it contains one electron. In short, species like this which contains only one electron, their energy and their radius can be calculated on similar basis. The only difference is, for example, if I want to calculate the energy for these species, it will be minus RH. Atomic number will be there on the top, z square divided by n square. And while calculating the radius, you have to take the same formula, same relationship, but divided by their atomic number. Its atomic number will be 2, Z will be 2, its atomic number will be 3, barium's atomic number will be 4, divided by 4. The relationship is similar to this, only atomic numbers are inserted because they contain the proton. Number of protons are more here. They have 2 protons, there are 3 protons, and there are 4 protons. Accordingly, the relationship or the formula of calculating the radius and the energy is it is being slightly modified, containing the atomic numbers. The last, the Bohr's theory says that the theory, right? It means that it's kind of assuming something, some points, and which is able to describe the few phenomena that are related to hydrogen atom, like the spectral lines, the atomic spectra of hydrogen. It can be related or explained through this theory. The fifth point is the velocity of the corresponding velocity of the electrons that are revolving in those stationary states, in those particular radii, in those with those permissible energy. The velocity of the electron can be calculated, although how the speed will be velocity will be calculated is not given. It can be calculated. So the Bohr was able to find to number the stationary states of electrons, of the electron, the radii in which they will be the radius in which they will be revolving, the energy that will be posed by the electron, and of the similar species. And he was also able to calculate the velocity of the electrons. This is Bohr's theory of hydrogen atom.